Is this working? Okay, good. All right, so file name expansion, you'll often see this term called globbing when you Google for it. Right? So file name expansion or globbing uses some special symbols in order for you to match multiple different file names. Right? So it uses these symbols called wildcards to help you succinctly specify groups of files, or file names, sorry. Right? Okay, so the special characters are the star, the asterisk, right? The question mark, and the left opening bracket. Now, if you've got a left opening bracket, you need the closing right bracket as well. But it turns out the way Bash works, the keyword, the character is actually, the special character is actually the left opening bracket. Right? So if you got one of these characters and they're not in quotes, right? So not in single quotes, not in double quotes, then your, wherever these things appear, they're interpreted as a pattern. And everywhere those symbols appear, the file names get replaced, sorry, the files names that the pattern matches get replaced. Right? So I'll give you an example of that in a moment. All right, so if you want to find out about these patterns using from the command line, you can type in that command there, man7glob. Right? So last class I was telling you about the man pages and how sometimes you had to specify sections. This is one of those times. If you just type man_glob into your command prompt, you end up with the documentation for the function called glob that's part of the Unix operating system. That's not going to help you. Right? So this is one of those examples where you have to know that there's another man page and it happens to be here. Right? So if you want to, you can scroll through that man page in your free time, right, and find out about and read the documentation for globbing. You can also click on that link there, and that takes you to the official GNU documentation for pattern matching. Right. Okay, so asterisk, question mark, and the square brackets are called wildcards. Right. A string is a wildcard pattern if it contains at least one wildcard, right? So not surprising. Right. Now, what do these wildcards mean? Okay, so the asterisk. The asterisk matches any string, including the empty string. Okay, so think about that for a second. So any string, including the empty string. Right? So if you just write some command space star, right, on your command line, then what happens is that star gets replaced with every file name that's in your current working directory. Because star matches anything, right? It matches any string. And the way the globbing patterns work, they match file names. Right? So in your current working directory, right, that star matches the name of every non-hidden file name. Right? Question mark will match any single character. Right? So A question mark B matches the string, or matches the file name ABC, AXC, A1C, anything. Right? So question mark matches any single character. If you have the square brackets and a bunch of characters inside the square brackets, right, then it will match any one of those characters. Right? The exclamation mark characters inside square brackets matches anything that's not inside the square brackets, right? Any single character not inside the square brackets. And then this funny notation here, square bracket, colon, some special name matches what's called a POSIX class, and I'll explain those at the end of this notebook. All right, so let's here's a bunch of examples. I'm just going to jump straight to the command prompt and show you some examples here. Okay, so remember I said star matches every file name, right? So in this directory, there's a few files. There's 4 files, right? So that's a good number to work with. It's not overwhelming, right? So if I do something like ls star, right, that star, right, matches every file name, every non-hidden file name that's in this directory. Right? What happens? All the matched file names replace the star. Right? So when I type ls star, oops, sorry. Okay, when I type ls star, it lists that file there. Right? Oh, so let me back up one. So writing ls star is the same thing as writing ls start here, bash c Jupyter kernel. Right? So that's what that star expands to, right? ls star, star gets replaced with the name of every file in the directory, right? So the star gets replaced with that file name there, right? And then all of these file names here, right? And so when you press enter, that's the output you get, right? It lists, sorry. Why is my, okay, so it lists that file there, which is right there, right? It lists the contents of that directory there, right? Because that is a directory name, so it lists the contents of the directory. That's a directory name, so it lists the contents of that directory. That's a directory name, so it lists the contents of that directory, right? So there's your start here.ipynb. There's your bash directory with all of its files. Right? There's your C directory with all of its files. And there's your Jupyter C kernel directory with all of its files. Right? So the star gets replaced with the name of every file that's matched. Right? So if you use a command like echo, right? So now echo is going to print the string that I ask it to print. Right? So echo hello will just print hello. Right? So what do you think echo star will print? Right? So echo star, so what happens with the star? The star matches every file name that's in the directory. Right? Echo will print that string. So it prints out the string bash C, Jupyter C kernel, start here, ipynb. Right? It's the exact same thing had I typed echo bash C, Jupyter kernel, and then start here. Right? Exact same thing. So that's what the expansion, that's what the term expansion or replacement means in bash. Right? Some construct gets expanded or replaced with whatever it evaluates to or matches. Okay, so if you just have a star, right? So we know that the star matches all non-hidden file names. Right? So what would a star match? Well, it matches all files that start with the lowercase a, right? So a, and then star matches any string, right? So any file that begins with the letter A will match a star. Right? Capital A star, right? So the string starts with the uppercase A. Star matches anything, so it's all files starting with the letter capital A. Right? Star.txt, that will match all file names that correspond to .txt files, right? So text files, plain text files. TXT is a common extension for plain text files. A star.txt, all files that start with A end in .txt. Right? Now what about the question mark? So the question mark matches any single character, right? It will not, I don't remember if it matches the empty character or not. I don't think it does. So question mark, question mark, question mark will match any 3-character file name, right? So it'll match the file ABC or 123 or whatever, XYZ. Right? It will not match AB, it will not match A, it won't match ABCD. X question mark Z matches any 3-letter file name that starts with X, ends with Z. Okay? So that's star and question mark. Now the square brackets denote what's called a character class. Right? So inside the square brackets, if you write something like Y, capital Y 1, 2, right? Then the file names that match that are any file names that start with an X, end with a Z, right, and contain one of those characters that are inside the square brackets, right? So it'll match XYZ, X capital YZ, X1Z, and X2Z, right? It'll match any one of those characters. If you put the exclamation mark at the front, it will match anything that's not one of those characters, right? So any single character that's not one of those characters. You're also allowed to use ranges when you define a character class, right? So A hyphen Z will match any 3-character file name, right there. XAZ through XZZ, right? So XBZ, XCZ, XDZ. So any 3-character file name where it's all lowercase letters starts with X and Z, ends with Z. Right? 0 through 9 will match any file name that starts with X, ends in Z, has a digit in the middle. Right? And you can combine these together in any order you want, right? So square bracket 0 through 9, square bracket 0 through 9, .pdf matches any file name that ends in .pdf, and its file name is made up of 2 digits, right? All right, so if you're in this directory here, so if you're in the scripts file name expansion directory, you're going to find a bunch of files. So I'm going to run this cell to switch into that directory. Right, so my Jupyter notebook is now in that directory right there. Right, so if I echo star, this is going to give you output that's similar to ls. Right, it's going to list every non-hidden file that's in that directory. Right, so you see there's a bunch of them. Right, so there's a bunch of these PDF files, a bunch of little text files, and so on and so on and so forth. Right. Okay, so using the wildcard pattern, right, you can match different files. Right? So let me just go to the console because it's easier from the console than it is from the notebook. So I'm going to be in bash scripts, and this is file name expansion. Yeah. Okay, so there are my files. Right? If I do ls star, right, what does the star match? It matches all file names in all non-hidden file names in the directory. Right? So it's going to list all of the file names in the directory. Right? Okay, so what if I wanted to get all of the files that started with capital F? Right? So ls, F star, will do it. Right? So you get those. If I want all of the files that start with a lowercase f, you just change the F to the capital F to a lowercase f. Right? Okay, what happens if I want all of the files that start with an F, whether it's an uppercase or lowercase? Well, it's easy. ls square bracket ff star. Right? And that gives you all the files that start with an F, whether it's uppercase or lowercase. Right? Okay, what else do we have in here? So we've got a bunch of PDF files. Right? Some of them have 2 digits in the name, some of them only have 1. So if we try the 0 through 9 trick here, .pdf, right? We get those files there. We don't get the 100.pdf because 100's got 3 digits. It doesn't have 2. Right? All right. Okay, now, a lot of the Unix commands, basically they accept file names as their inputs, and then it does something with the contents of those files, well, either with the names of those files or with the contents of those files. Right? So the cat program will read the name of any file that you give it as an argument, and then display the contents to your terminal. Right? So cat is short for concatenate. So read the contents of the file, output them to the screen. So cat star.text will read every .text, every file that ends in .txt, and print their contents to the screen. Right? So let's look at all the .txt files. There's 2 of them. Right? I can cat any one of them by giving it just its file name. Right? I can cat the other one just by giving it its file name. So you can see here all these words start with a capital A. Right? All of these ones are going to start with a lowercase a. Right? If I want them all, I just cat star txt. Right? And you'll get the output of all of them catted together, concatenated together. Right? So a lot of the Unix programs will accept an arbitrary number of files. You can use wildcard, you can use file name expansion to process all of the files at the same time. Right? Turns out to be extremely useful. All right, now what about these funny POSIX character classes? So one of the problems with using a construct like little a hyphen z is that only works with if you happen to be working in the English language. Right? If you're working in a different language, and then you might want to list files using your own native language. Right? So you might want files starting with some symbol in your language up to some other symbol in your language. So these things called POSIX character classes that are designed for that sort of thing. Right? So let's look at alpha. No, let's look at lower first. Okay. So square bracket, colon, lower colon, square bracket matches any lowercase letter, right? If you're in the standard English-speaking Bash, right, then that matches the lowercase letters A through Z, right? If you're in some other language, it'll match whatever the lowercase letters are in that language, as it's defined by what's called your locale, right? But that's a topic that's way beyond the scope of this course, right? There's a corresponding class called upper, right? So square bracket, colon, upper, colon, square bracket. That matches all the uppercase letters, right? Square bracket, colon, digit, colon, square bracket are the digits 0 through 9, right? So to use these, you have to put these in square brackets. So that's why it looks like double square bracket, right? So for example, ls, 2 square brackets, colon, digit, colon, square bracket, star. Right? That says match all file names that start with a digit. Right? Not surprisingly, you get all of the, well, you get all the file names that start with a digit. Right? Okay, so you can use the POSIX character classes if you want to. It's a lot wordier to write, right? So it's a lot, you have to write a lot more to get these out. But they are convenient if you need to write a multilingual script, which is a bit unusual, to be blunt. But if you have to do it, you can do it using the POSIX character classes. Right? And there's a whole bunch of them. Right? Don't memorize what these are. I'm never going to ask you about these on a test. Right? So don't memorize what these all mean. Right? All you need to know is that they exist. Okay? So here are some examples. Right? Square bracket, colon, upper colon, square bracket, star matches any file name that starts with an uppercase letter. Right? You can use the not. So you can use the exclamation mark here, right? So exclamation mark in front of a POSIX character class negates the character class, right? So in other words, not square bracket, colon, upper colon, square bracket, all files not starting with an uppercase letter, right? And again, you can combine them with the other letters and other wildcards, right? You can combine them with other character classes as well. All right, so there's globbing in a nutshell. Any questions? How long did that take? Sorry. Okay, super. Next notebook. So that's file name expansion. Now we're going to do quoting, which is another short notebook. So that stuff I just showed you should throw up, right away you should start to ask some questions, right? You should say, hey, what if I have a file name that's got a glob character in it, right? How do I get that back out, right? Or what if I have a file name that has a space in it, right? Because spaces, they separate things in the bash shell, right? So if you have a file name with a space in it, how do you write out the name of a file name with a space in it? Right? And so that's what quoting is used for. Oops, sorry, wrong key. There we go. All right, so we've seen that some characters have special meaning to the shell, right? So star, the asterisk, sorry. The forward slash is special because it's the directory separator. Question mark, square bracket, these are all special. There's a bunch of other special characters as well, right? Space is really important in bash, right? Space separates what are called tokens in bash. Right, so bash wants to use the space as the word separator. So if you have a file name or a string that's got spaces in it, processing with bash requires some special, requires you to do something to accommodate the string, the space, sorry. Right? So the way you deal with this is you use what's called quoting, right? And quoting doesn't always mean quoting in bash. So let's look at what quoting exactly means. All right, so again, if you're using the notebook, run that cell once so that it puts you in the correct directory, and that will drop you into the directory that's got all of the appropriate files. Right? Okay, so but let's see, I guess if you've taken Java, you might have seen \n, that's the new line character, or \t, that's the tab character. You might have seen them in Python course as well, right? So that \/ character is what's called the shell escape character, right? If you're wondering where it comes from, well, its roots start all the way back in Unix, right? So what does the \/ actually mean? So if you write \/ followed by a character, whatever that character is, the literal value of that character gets preserved. Okay? So \* does not do file name expansion. Right? \* means I really want to match the asterisk. Right? \# means I really want the question mark. I don't want to do file name expansion. Right? \space means I really want the space character. Right? I don't want to separate these two words. Right? Now the question is what exactly constitutes a special character? The answer is not at all obvious. If you search for it, you'll eventually hit this Stack Overflow question, where someone has provided a lovely bash script that will actually print out every character that might need escaping. Right? So we're not quite ready to understand this program yet. You'll be able to understand it, I think, in a couple of weeks. Right? But all this is doing is it's taking all of the characters that you can type in easily from your keyboard, right? And it's going to loop over each one of those characters, and then it's going to use this this command called printf to determine whether or not you have to deal with this character specially. Because printf has a flag, has an option that lets you know if this is a meaningful character or not. Right? So if you run this program, bloop, bloop, right, there you go. Right? It tells you if I want to use the percent sign, right? Yeah, if I want to use %, that's fine. It's not special to the shell. Right? Plus sign's fine. The hyphen is normally fine, but I'm going to tell you when it's not. Right? Period is fine. Right? / is fine, but that's the directory separator, so you can't really use it in a file name. Right? Colon is fine, and so on and so forth. But look at all these ones that need special treatment. Right? If you have a $, you probably have to treat that specially. The space needs to be treated specially. Right? Exclamation mark needs to be treated specially. That's not surprising, because I just showed you examples where we're using the exclamation mark to negate a character class. Right? Quote, and so on and so on and so forth. Right? So there's a bunch of special characters that you have to be aware of. In particular, you should avoid using these special characters in a file name, because as soon as you use them in a file name, you now have to deal with these specially when you try to access these files. Right? And that includes this space, right, which is very common. Right? So you know, if you're a Windows or a Mac user, you're used to just typing in file names with spaces and special characters and stuff in them. Right? Usually everything works. Every once in a while, especially on Mac, something will surprise you. Last year, someone had a directory that had a colon in it. The problem with a directory that has a colon in it is the colon is what's called the path separator. So your shell uses the colon to separate directories in what's called the path. If you put a directory with a colon, if you have a directory with a colon in the name on a Mac, that can screw up things if you have an executable program in that directory. That one took a lot of debugging to find. Anyway, avoid special characters in your file name in Unix. Now the problem is, do I tell you anywhere of this? Where is it? Okay. I actually don't. There's a notebook that tells you what to name your file, how you should name your files. A second here. And I don't remember which one it is. And I suspect is it this one? Okay. Oh, I do. Okay, so it's going to be in the next character here. All right, file names. All right, so when you're naming your files, right, you've seen that there's a bunch of characters that are special. If you put those special characters into a file name, you have to escape them in order to write down the name of the file. Right? Otherwise, the shell interprets it as special. Right? File names are case sensitive. Right? So little ABC as a file name is different than big A, BC. Right? Those are two distinct file names. If you name your file name starting with a period to bash, or to most shells, that's considered a hidden file. Right? Most programs and the globbing will not match any file that starts with a period. If you want to match those, you have to explicitly put in the period yourself. Right? So for example, .* will match any of the hidden files. Right? Finally, all of these characters here, right, those potentially have meaning to bash. So you should generally avoid those in a file name. Now here's the problem. In Unix, there are no forbidden file name characters, right? Except for, where do I tell you this? Oh, I don't tell you anywhere. Okay, so you cannot use the / in a Unix file name, or a Linux file name, or a Mac file name, right? Because the / is the directory separator. That is the only forbidden character in a Unix file name. That means you can have things like the new line character as part of your file name. And that screws up things like ls. Right? So when you type in ls and you type in -1, you get one file per line, right? One file name per line. Unless your file name has a new line character in it, and now that file name appears as two separate lines. So if you try to count up the number of lines that ls produces, you get the wrong file name count. So if you search online, you'll see a lot of advice that says when you write a script, don't use the output of ls to process files. It's because of all these funky characters that might appear in file names that have special meaning to the shell. Right? So in this course, avoid any unusually named files. Right? Stick to letters, numbers, digits. Right? And the period is okay. Anything else you should generally avoid. When you go out to work, if you end up in a system administrator job, you have to be aware of the fact that people will name their files with funny characters in them. You have to do something special to deal with them. Right? You will not be surprised with that in this course, right? So no one's going to give you, no one's going to try to intentionally sabotage your script by giving you an unusual file name. Okay, so putting spaces in file names is pretty common because a lot of people have come from a graphical user interface like Windows or Mac, where it's common to put in space. It's common to name files with spaces in them. Right, so it is pretty common to have to deal with this problem on Linux or Unix as well. Right? One way to deal with the space or to put a space in a file name is to escape the space, right? So \space. Right? All right, so let's run this ls command in this directory. It's got a bunch of files with some funny names. Right? So we've got, oh wait, wrong directory, sorry. I'm pretty sure that's the wrong directory. Run this. Okay. And now go back and rerun this one. Okay, that's better. Right, so in that directory, I've got some files with some very unusual names. Right, there's one. It's got a star in it. We know what star means, right? Matches anything. Question mark, we know that means match any single character. Right? Space, we know that that separates words in, well, a bunch of spaces. Right? So we know these separate words or arguments, right, in bash. Right. Okay. When you write ls, or when the ls prints the name of a file, if there's an unusual character in it, it surrounds it with single or double quotes depending on the context. Right? So if you ever see a quoted file name in the output of ls, that's because there's a special character in it. Okay, so the single quotes, they're not part of the file name. The shell has inserted them so that it can deal with the fact that there's some special characters in this file name. Right. Okay, what if I want to use this file name as the name as an argument to a command? Right. So for example, what if I want to see what's in the contents of this file? Right. Well, I have to escape the special character. Right. So \* will show me the contents of that file, right? So in that file is avoid using star in file names, right? Don't do this, right, when you're renaming your files, right? It's just going to complicate your life. All right, now what happens if I get rid of that slash? Oh, so now what's happened? Remember that star matches any string, right? So what is that star going to match? Right? It's going to look for a file that starts with file _ with _, right? Anything. _ name. There's two files that match that, right? There's that one, and there's that one, right? So if you forget to escape the asterisk, right, then that asterisk gets expanded using a file name expansion, right? And it ends up matching that file name and, right, And so that ends up being the following with slash question mark underscore in name, right? So if you omit the escape character here, right? Then when this expands, it expands to 2 file names because there's 2 file names that match the expansion, right? And now cat outputs the contents of both files, right? Okay, so same thing with the question mark, right? If I want to look at the contents of that file, right? And I want to specify the name of the file on the command line, then I have to escape that special character. Right? When I do that, you get the output of that, you get the contents of that file. Avoid using the question mark in your file names, right? Again, if you omit the escape character, now file expansion happens, right? That matches any file that's got a character, that's got a single character where that question mark is. So it's going to match the star, and it's going to match the file name with the star in it. It's going to match the file name with the question mark in it. If I run it, you're going to get the output of both files again. Right? And finally, there's that file name that's called file space with, right? And so on and so on and so on, right? If I want to use that file name on the command line, I have to escape all of those spaces, right? And not surprisingly, the contents of that file say avoid using spaces in the file name. Now, what happens if you don't do that? Right? So, if I don't do that, right, then what cat gets the input file with spaces in and name. So it's going to look for a file called file and try to concatenate the output of that file. It's going to look for a file called with, right, and try to concatenate the output of that file, and so on and so on. Right? So here it's going to barf no such file or directory, no such file or directory, no such file or directory, right, and so on and so on and so forth. Right? So if you're going to use the space, right, one way to deal with it is to escape every space, right? After you've done this a few times, you'll stop naming your files with spaces in them, because this is a pain in the butt. Okay, so the escape character falls under the category of quoting in bash, right? Even though it's not quoting, right? It's escaping special characters. So what do the quotes actually mean in bash? Okay, so you've got single quotes and you've got double quotes. There are no triple quotes. There's no triple single quoting or triple double quoting in bash. So the single quotes, if you put something in single quotes, then every character in that, inside the single quotes, every character gets its literal meaning. Right? So in other words, nothing is special inside the single quotes. Right? That includes the backspace, the escape character. Right? So if you put the escape character inside of single quotes to try to escape a special character, it doesn't work. Right? Inside single quotes, everything gets treated literally. Right? So one way to deal with these files is just to put them in single quotes. Right? Now the star is not special. Right? The question mark is not special. The spaces are not special. Right? So single quotes prevents all expansions in bash. Right? And there's a bunch of expansions I haven't told you about yet. Right? So if you need to prevent every single possible expansion, single quotes are what will happen. Will do it. Right? Now, you're going to see later on that you don't want to prevent all expansions. Right? There's many cases where you want some of the expansions to occur, and that's when you use double quotes. Okay, so double quotes preserve the literal values of all characters except for a few special ones. That's wrong. Sorry, that's, oh, that's why. I didn't escape the escape character. There you go. Sorry, that's a mistake. If you're looking at slash code as HTML, that's what it's supposed to be. All right. Okay, so inside double quotes, the $, the backtick, the escape character, and sometimes the exclamation mark, those still retain their special meaning, right? Later on, you'll learn what the $, does, right? The backtick is an old construct. We won't be looking at it in this course. That you know what it means, right? So that you know is the escape character. Okay, now inside double quotes, that escape character doesn't work the way you expect it to. Okay? So inside double quotes, the only characters that are escaped is that. So you can write backslash to get the character backslash. You can write backslash $sign to get the $sign. You can write backslash backtick to get the backtick. You can write oh, there it is again. You can get backslash double quote to get the double quote. Right? You can also escape the new line character, but that's hard to put into a string anyway. Okay, so it turns out double quoting is very common in Bash. Right? So when we start talking about scripting, you're going to see all sorts of stuff double quoted. Right? The main thing that double quoting does is it prevents word splitting. So wherever there's a space, the space retains its, the space does not split the word. Right? It keeps its literal meaning. Right? So the space is the space. Right? And so that turns out to be very useful when working in Bash scripts. Right? So these also work. Right? So another way to deal with these funny file names is to put them in double quotes, and they all work. Right? So inside double quotes, star loses its special meaning. Question mark loses its special meaning. The spaces lose their special meaning. Right? So here, this isn't going to make any sense to you if you're reading it. Right? So double quoting prevents word splitting. Right? So there's where I mean it prevents word splitting. Right? It lets me treat that all as one big word. Right? So that's number one. It prevents file name expansion. Right? So in other words, star, question mark, square brackets, they lose their special meaning inside double quotes. Tilde expansion doesn't work either. Right? So if you try to, well, let's try to do it. Insert cell. Right? So what happens if I try to cat? Sorry, I need the name of a file that's in my home directory. Oh, hang on. I think I killed my, oh, there we go. Let me do this from the command line. Oh, there is nothing there. All right, so try cat tilde CISC220. Start here. Okay, so there's the contents of your start here file. Right? And I did that by typing in that. Right? Now, if you quote the tilde, right? So remember what tilde means on its own? Tilde on its own gets replaced with the name of my home directory. You put it inside double quotes, tilde doesn't mean anything. So now it says, hey, I can't find this file called tilde / blah, 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 blah. Right? So tilde, the double quoting also prevents tilde expansion. Right? So that's what all of that means. Now, there's a bunch of other things here that are listed that we haven't talked about yet. Right? So those other things still occur inside of double quotes. And these other things become a lot more useful when we start to write our own scripts. Cool. All right. Any questions so far? Super. You know almost everything, I think, that you need to know for assignment 1. Almost. The next notebook will cover everything else that you need to know. But for now, we're good for assignment 1. Take a look at assignment 1. Give it a shot. It's not too bad. And we'll pick this up on Friday.